Definition. A permutation is an ordered arrangement in which R objects are chosen from N distinct means different objects, so that R is less than or equal to N and repetitions not allowed. The symbol, lowercase subscripted n, uppercase P, subscript R, represents the number of permutations of R objects selected from N objects. So this notation, NPR, that's a pretty common notation. Another notation that's used a lot you might see for the same thing is you might see P and then in parentheses have N comma R behind it. That's a pretty common notation as well. Well, with the permutation, we're going to pick a certain number of items, and the order in which those items occur is significant. The order matters. So for example, suppose up here in my 8 songs, suppose I wasn't going to have time to listen to all 8 songs. Suppose I was only going to be able to listen to maybe 3 songs. So if I'm using the random player, so songs can't repeat, but I'm only going to have time to listen to 3 songs, then how many ways could I choose those 3 songs? Well, if I'm picking from 8 items, but I'm only going to have 3 of them, or only 3 are randomly being played out of the 8, that would be a permutation of 8 items, choosing 3 of them. So N would equal 8 and P would equal 3. That's how I would denote that. So I'm choosing 3 items out of 8, and the order is significant. Example. A committee consists of 10 members. How many different ways can offices for chairperson, vice chairperson, and secretary be filled? So a committee is made up of 10 people. So N equals 10. Our question is, how many ways can the offices of the chair, the vice chair, and the secretary be filled? So we're going to pick 3 people for offices. So R equals 3. So we have 10 items and we're picking 3 of them. Now our question is, again, how many different ways can that happen? Well, the order in which a person is selected matters. So there would be a difference between the person being selected first, because if they're selected first, they're the chair. But if they're selected second, then they're the vice chair instead of the chair. And if they're selected third, then they're the secretary instead of the chair or vice chair. So the order that the individuals are selected is significant. The order matters. So this is a permutation. Specifically, this would be a permutation of 10, and we're picking 3. Now, the way we're going to calculate this permutation is this. We can do it actually a couple of different ways. I'm going to give you a formula in just a minute. So I'm picking 3 individuals. For the first individual, for the chair, there would be 10 people to pick from. But now, after the chair has been picked, for the vice chair, there's only going to be 9 people left to pick from. And now, when I'm going to the secretary, the chair and the vice chair have been picked, there will only be 8 people left to pick from for the secretary position. So 10 times 9 times 8, and 10 times 9 times 8 is 720 if you multiply that out. So the answer, there are 720 different ways of selecting these 3 offices. Formula. The number of arrangements of R objects chosen from N objects in which 1, the N objects are distinct. That's important. I have to be able to tell the objects apart. They have to be distinguishable. So like with the 10 people on this committee, they're distinct. We can tell those people apart. The 8 songs on the iPhone, they're distinct. We can tell them apart. So that is a condition. Repetition of objects is not allowed. So you can't have the same individual twice. The person can't be chair and secretary both, right? So repetition's not allowed. The same song's not allowed to play twice on the iPhone until all 8 have played. Order is important. And by important, I mean significant. Order significant, meaning that one being first and the next one being second is different from this one being first and this one being second. Order matters. They're different results. Anyway, that's going to be given by the formula. NPR equals n factorial divided by n minus r factorial. So if I pull back in this problem, in this problem, n is 10, r is 3. So according to our formula, that is going to equal 10 factorial, that's n factorial, over 10 minus 3 factorial. That's n minus r factorial, and that's our formula here. N factorial over n minus r factorial. Now, 10 minus 3, that's 7. So that would be 10 factorial over 7 factorial. Now, 10 factorial would mean 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 factorial would mean 7 times 6 times 5 times 4 times 3 times 2 times 1. And so the 7s would cancel, the 6s would cancel, the 5s, 4s, 3s, and 2s would cancel. And I guess I'll say the 1s cancel too, although those don't matter. And that leaves 10 times 9 times 8, which is equal to 720. So this formula will work, and it will always work. Look up here at this problem. Now, at this problem, we had 8 songs, and we were going to play all 8 of them. So that would be a permutation of 8, choosing all 8. So if I'm choosing all 8 out of the 8, then that means n equals 8 and r equals 8 also. So by our formula, that would be 8 factorial over 8 minus 8 factorial. Now 8 minus 8 is 0, so I would have 8 factorial over 0 factorial. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, so that would be 40,320. 0 factorial, we said, is defined to be 1. This right here is why. 0 factorial has to be 1 in order for this to work out to be the 40,320, for example. And not just this one problem, but for these problems in general. So that's why 0 factorial is defined to be 1, so that we're dividing by 1 in this kind of case, which gives us the correct answer of 40,320. Another example. How many 3-letter arrangements are possible using the letters A, B, C, D, E, F, G, H? Letters may not be repeated. So we're going to choose 3 letters, and our question is how many 3-letter arrangements are possible? So like A, B, C, that's one arrangement. A, B, D, that's another arrangement. A, B, E, that's another arrangement, and so on. B, A, C is another arrangement. B, A, D is another arrangement. B, A, E is another arrangement, and so on. B, C, D is another arrangement, and yada, yada, yada. So we have 1, 2, 3, 4, 5, 6, 7, 8 different letters, and we're going to choose 3 of them to arrange. So we have 8 letters, so that's 8 distinct objects. I can tell the letters apart. Letters may not be repeated, so repetition of objects is not allowed. The order is going to be important. The order is significant. If I have A, B, C, that's different from B, A, C, or C, A, B, and so on. So the order matters. So this is going to be a permutation of 8, choose 3. We have 8 objects that we're picking from, and we are picking 3 of them for a 3-letter arrangement. So based on our formula, that is going to be 8 factorial over 8 minus 3 factorial. Now 8 minus 3 is 5, so that's 8 factorial over 5 factorial. Now 8 factorial means 8 times 7 times 6 times, I'm going to say 5 factorial. 5 factorial is going to keep going down to 1. 5, 4, 3, 2, 1. But on the bottom, I have 5 factorial, which is also going to do 5, 4, 3, 2, 1. So the 5s would cancel, the 4s would cancel, the 3s, the 2s, and the 1s would cancel. So I'm not going to write them all out. So I'm left with 8 times 7 times 6. And 8 times 7 times 6 is 336. So there would be 336 different arrangements of 3 letters if letters cannot be repeated. Oops, I didn't put my units on there. That would be arrangements. So 336 arrangements. Now, if I was allowed to repeat letters, I wouldn't get the same answer. If repetition of letters was allowed, then I could have like A would be one possible arrangement. So if repetition was allowed, it would be 8 times 8 times 8 would be the answer. And 8 times 8 times 8, that would be 512 instead of 336. So you got to pay attention to the wording. It matters how we compute things. If repetition's allowed, it would not be a permutation. I do want to point out on your calculator, if I go to Math PRB, look at option 2 right there, NPR. That is a command that allows us to compute permutations on our calculator. Here's how it works. The first thing I'm going to do is I'm going to type 8. Then I go to Math Probability NPR and select that. And then I type in the 3. So I get 8P3. And when I hit enter, the calculator calculates that and tells me it's 336. If you have a newer calculator like mine, it's going to work just exactly like mine. If you have an older calculator, it's going to look like this. You're going to type the 8, and then you're going to go get that NPR command. But when you choose the NPR command, it's literally going to put NPR on your screen behind the 8, and then you put the 3 behind that. So 8 NPR 3, and when you hit enter, you're going to get the 336. A combination. A combination is a collection without regard to order in which R objects are chosen from N distinct objects, with R less than or equal to N, and without repetition. The symbol NCR represents the number of combinations of N distinct objects taken R at a time. So a combination is different from a permutation. And the difference is, in a permutation, the order is significant. In a combination, the order is not significant. So that's why it says without regard to order. So for example, if I'm looking at my letters here, okay, if I'm making an arrangement of letters, if ABC and ACB, if those are different results, then the order is significant, and we would have a permutation like we did here. But if instead of these just being letters and I'm making a word out of it, suppose these are representing people. So we have Andy, Bill, Clint, Daryl, Eric, Ford, Greg, and Harry. So if those are 8 people, and let's say I'm going to pick 3 of those people to go with me to Chicago. How many ways could I pick 3 of the 8 people? Well, if I pick Andy, Bill, and Clint, it doesn't really matter if Andy's picked first, Bill's picked second, and Clint's third, or if Andy's first, Clint's second, and Bill's third. They're the same 3 people going to Chicago with me. So if I change the scenario where the order isn't significant, that changes my calculation. There wouldn't be 336 different ways that I could pick 3 of my friends to go to Chicago with me. Because again, ABC would be the same as ACB, and that would be the same as BAC, and that would be the same as BCA, and that would be the same as CAB, and that would be the same as CBA. If those 3 people are picked, all of these are the same result, really. The order's not significant. It's just the same people. The symbol NCR represents the number of combinations of n distinct objects taken R at a time. Example, a committee consists of 10 people. How many ways can 3 members be selected to attend a conference in Las Vegas? So I'm going to pick 3 people to go to a conference in Las Vegas. So the idea is the same here. If it's Andy, Bill, and Clint, or Andy, Clint, and Bill, or Bill, Andy, and Clint, or Bill, Clint, and Andy, or Clint, Andy, and Bill, or Clint, Bill, and Andy, all 6 of those outcomes are the same outcome. Those would be the 3 people going to Vegas. So this problem is different from this problem. This would be a combination instead of a permutation of 10, and I'm choosing 3. Now here's the deal on how I'm going to calculate that. And by the way, I did that problem because it's very similar to this problem. In this problem, we had a committee with 10 people, and we're picking 3 offices: chair, vice chair, and secretary. So the order that the individuals were selected was significant. Here, I'm picking 3 people out of 10, but the order doesn't matter, because what matters is if they get picked or not if they're picked first, second, or third. Here, being picked first, second, or third matters. Here, being picked first, second, or third doesn't matter. So what do we do? Well, I'm going to take that permutation of 10, choose 3, and I'm going to divide that by the number of repetitions that are the same result. So the number of repetitions that are the same result would be 3 factorial. 3 times 2 times 1, 6 in other words. Now we figured out on the previous page that 10 permutation choose 3 was 720. So there's 720 ways that these people could be picked, except there's repetitions in there that we need to remove. Again, these 6 outcomes are all the same result, really, when we're talking in this case. So 3 factorial means 3 times 2 times 1, that's 6. And if I take 720 and divide by 6, that's 120. There are 120 ways that 3 people could be picked out of the 10 to go to the conference in Vegas. So again, I'm dividing by 6 because for each group of 3, there's going to be 6 groups that really result in the same outcome, the same people going. So as a general rule, the number of different arrangements of R objects chosen from N objects in which, 1, the N objects are distinct, so I got to be able to tell the objects apart. 2, repetition of objects is not allowed, so Andy can't go twice to Vegas. Order is not important. So if you look at the difference between up here and down here, everything's the same except part 3. Order is important in a permutation. Order is not important in a combination. And again, by that I mean it's not significant. So again, the order of these 3 people doesn't matter in this scenario. Anyway, that's going to be NCR equals N factorial divided by R factorial times N minus R factorial. Now, I just want to point out N factorial over N minus R factorial, that's the permutation formula. So we're taking the permutation formula and we're dividing by R factorial, which is what I did right here. I took the permutation formula and divided by 3 factorial, that's the R. and that gives me this result. So that is, like in this case, that would be 10 factorial divided by 3 factorial times 10 minus 3 factorial. And so that would be 10 factorial over 3 factorial times 7 factorial. Now, if we take a look at that, 10 factorial means 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. 7 factorial means 7, 6, 5, 4, 3, 2, 1. 3 factorial means 3 times 2 times 1. Now, the 7, 6, 5, 4, 3, 2, 1 on the top and bottom is all going to cancel out. And I'm lazy, so I'm not going to write 7 all the way down to 1 twice so I can cancel them out. So I use 7 factorial for that. 3 will cancel with 9, leaving 3. 2 will cancel with 8, leaving 4. And so I have 10 times 3 times 4. Well, 10 times 3 is 30, and 30 times 4 is 120. So that's going to equal 120. On our calculator, like we had the permutation command, we also have a combination command. It's option 3 on my calculator. So if I do 10, math, probability, combination 3, the calculator will calculate that for me. That's 120. And again, if you have an older calculator, the command would be 10 NCR 3. That's how it would look, and you press enter. And it'll give you the 120. So the trickiest part about combinations and permutations is paying attention to whether the order matters. Is the order significant for the objects? Example. In a game of poker, a hand consists of 5 cards that are dealt from a standard 52 card deck. How many different poker hands are possible? So would this be a permutation problem or a combination problem? Does the order of the cards that you're dealt matter in a hand of poker? Does it matter if you get like the king of spades as your first card versus your second, third, fourth, or fifth card? It doesn't matter, right? What would matter is maybe if you have the king of spades in your hand, but it doesn't matter which place it was dealt to you in your hand. So the order in which you're dealt the cards doesn't matter in a poker hand. So this would be a combination. So we do have 52 distinct objects. The cards, you can tell them apart. Repetition's not allowed. You're not going to get the same card twice in a standard 52 card deck, and order in a poker hand doesn't matter. It's not significant. So this is a combination of 52, choose 5. Now, if I had to calculate this by hand, this is going to be 52 factorial over 5 factorial times 52 minus 5 factorial. That's our formula. That would be 52 factorial over 5 factorial times 52 minus 5 would be 47 factorial. Notice these two numbers on the bottom, 5 and 47. They're always going to add to the number on the top. 5 plus 47 is 52. That's really how I think about those two numbers. Now, 52 factorial is going to mean 52 times 51 times 50 times 49 times 48, and really times 47 all the way down to 1, right? But I'm going to say 47 factorial because this 47 factorial on the bottom is going to be the same 47, 46, 45, and all of that's going to cancel out. 5 factorial means 5 times 4 times 3 times 2 times 1. Now, all of this should cancel out. Like 5, for example, can cancel with 50, leaving 10. 4 times 3 times 2, that is 24. And 24 can divide out of 48. So 48 divided by 24 is 2. And 4 times 3 times 2 times 1 is the 24 as well. So everything's canceled. I'm left with 52 times 51 times 10 times 49 times 2. So 52 times 51 times 10 times 49 times 2, that would be 2,598,960. 2,598,960 different hands. So there are 2,598,960 different poker hands that can be dealt from a deck of cards. We could have also used our calculator. We could have typed 52, math, probability, combination, choose 5, and that gives me the same answer. I would really recommend doing it the second way, but I want you to understand the arithmetic that's going on as well.